All right. So, continuing on through chapter 3. Before we do that, though, look back to last time. Last time we were looking for where are we increasing, where are we decreasing. So, what we did was the first derivative test. So, find the open intervals on which f of x equals x to the third minus 3 over 2, so 3 halves x squared is increasing or decreasing. So, the first thing we got to do is find the first derivative. So we bring the 3 down in front. This becomes 3x squared. Bringing the 2 down in front would cancel with the 2 down on the bottom, which would be a minus 3x then. Now from there, we're going to set it equal to 0 and we're going to solve for x. So we can pull a 3x out and we would have x minus 1 left in. So the 3x would go to 0 and the x minus 1 would go to 1, and those would be our critical numbers. So we're going to set this up. So we have 0, we have 1 as our breaks. So the intervals would go from negative infinity to 0, 0 to 1, and 1 to infinity. So some test values. Let's go negative 1. Let's go 0.5. And let's go 2. Now, if you put this into your graphing calculator, you'll put this first derivative in. So if you had something there cleared out, we'll do 3x squared minus 3x, and then we'll hit second table, and we're going to delete whatever's here. And so we're going to put in our test values now of negative 1, 0.5, and 2. So 6. So positive, negative, positive. So all we're worried about here is just the sign. So positive, negative, positive. So when the first derivative's positive, we're increasing. When we're negative, we're decreasing, and then increasing. Okay. Now, we can look at this and go, okay, if we're increasing to decreasing, this is a max. And if we're decreasing to increasing, this is a min. Okay. Now, moving on. So the next thing we're going to hit is concavity. Concavity is basically where we're switching from either curving up or curving down. So if you think about it, where like this would be concave up, because as we're curving towards the up. This would be concave down, because as we're curving back down. So it's as we're curving either way. So the test for concavity, whether we're concave up or concave down, so curving up or curving down, I should say, is the second derivative test here. Or not second derivative test, but using the second derivative. So when the second derivative is positive, we're concave up. If our second derivative is negative, we're concave down. And if we equal 0, then the test fails. All right. So determine the open intervals on which the graph of 6 over x squared plus 3 is concave up or down. So the first thing I'm going to do is find the first derivative. So the derivative of the top would be 0 times the bottom minus derivative of the bottom, which would be 2x times the top. So that'd be gone all over the bottom squared. So x squared plus 3 squared. So we'd get x squared plus 3 squared. Here, 6 times 2 would be 12. With the minus would make this a minus 12x. Is your first derivative. Second derivative now. So again, quotient rule, which is what we did here. Derivative of the top would be negative 12 times the bottom of x squared plus 3 squared minus the top, negative 12x, times derivative of the bottom. Well, we got to do chain rule here. So 2 parentheses x squared plus 3 times derivative of the bottom, which is 2x, all over the bottom squared, which was x squared plus 3, If it's squared already, it becomes to the fourth. Now, to simplify this, well, we have an x squared plus 3 here, an x squared plus 3, and x squared plus 3. So we can get rid of this one of these, and one of these to make this to the third. So now we have on the bottom x squared plus 3 to the third. Now this first part, then we can distribute the 12 in and have negative 12x squared minus 3 times 12 would be 36. Here, well, 2 and 2x would be 4x. 4x times 12x would be 48x, and the negatives cancel, so plus 48x squared, because that is square x and an x, yeah. So, to simplify this, we would have, so negative 12x, positive 48x is 36x squared minus 36 over x squared plus 3 cubed. Now, since I ran out of room, I'm going to do it down below here. But to find where this equals 0, all we have to worry about is where's the top 0. So 36x squared minus 36 equaling 0 at. So I can add the 36 over. So 36x squared would equal 36 divided by 36. X squared would equal 1. So when we square root, x would equal plus or minus 1. So those are going to be our breaks. So negative 1 and 1. This is that possible point of inflection. So P of I. So points of inflection are where it's going to switch. I'm getting ahead of myself. I'm sorry about that. But either way, these are going to be your deals. So our first one would go from negative infinity to negative 1. This one would go from negative 1 to 1, and then 1 to infinity. So test value, I'm going to go negative 2, 0, and 2. So again, I'm going to put this in my graphing calculator. So go back to your y equals, clear this out, and this is what I'm going to put in. So in parentheses, because you need the entire top in parentheses, the entire bottom in parentheses. 36x squared minus 36. Close the parentheses, divide another set of parentheses for, and I'm going to do a couple here just to make sure, but x squared plus 3 in a set raised to the third power, and close that set. So second table, negative 2, 0, 2. And it doesn't matter what the numbers are here, but we are positive, negative, positive. Positive, negative, positive. So this would be concave up, concave down, and concave up. All right. So it's which way it's curving. So if you think about it, this one's going to be curving this way. This one will be curving this way. This one will be curving this way. So the P of I was talking about, points of inflection. So that's where it switches. So if we're going up to down, that's the point of inflection. Down to up, that's a point of inflection. Which I believe we talk about here in the next one. Points of inflection. So it's where it changes from up to down or down to up. So find where it's concave up or down. So the first thing I'm going to do, first derivative. So derivative of the top would go to 2x times derivative of the bottom, x squared minus 4, minus derivative of the bottom, which would go to 2x, times our top of x squared plus 1. over x squared minus 4 the bottom squared. So to simplify this, you have 3x cubed minus 8x. If we distribute it in here, we'd have a minus 2x cubed minus 2x. So x squared minus 4 squared. 3x cubed minus 2x cubed would be an x cubed. And negative 8x, positive 8x. No, negative x, negative 2x would be minus 10x. Sorry. I feel like I did something wrong. Why is that 3x cubed? This should be 2. Haha, so those should cancel. Okay, my bad. Knew something wasn't quite right there. So, first derivative, negative 10x over x squared minus 4 squared. Second derivative. Derivative of the top would just be negative 10 times the bottom, x squared minus 4 squared, minus the top, negative 10x, times the bottom, derivative of the bottom, which we do chain rule here, 2x squared minus 4, times derivative of the inside, which would be 2x, all over the bottom squared. Well, if we're over squared, squared becomes to the fourth. Now, same thing as last time, can cancel 1, cancel 1, cancel 1. So we would have on the bottom here, x squared minus 4 to the third, negative 10x squared plus 40. Here, 2x and 2 would be 4x. 4 times 10 would be negative 40. X and x squared makes it plus 40x squared, which would end up being x squared minus 4 to the third. On top here, we would get, so negative 10x and 40x would be 30x squared plus 40. So again, find the points of inflection. Set it equals 0. So 30x squared plus 40 equals 0. Well, we would have 30x squared minus 40 equaling negative 40. So we'd subtract the 40 over. Well, if we divide by 30, we get x squared equaling a negative 4/3. Well, when we square root, we're going to square root a negative. I'm off the screen, sorry. Which means that causes an issue. So the other thing to check is what would make the bottom be 0? Well, 2 to the third means we're just going to have 3 multiples of these, but the bottom can factor out. I don't know if I checked the bottom on the last one. The last one, it was x squared plus 3, so there's no way to make that be 0. That's why we didn't worry about it. Knew there was a reason. So the bottom here, think it's a difference of squares of x plus 2, x minus 2, even though there's 3 sets of those, which means we'd have discontinuity at plus or minus 2. So that's where we're going to have our possible points of inflection. So negative 2 and 2. So interval goes from negative infinity to negative 2, negative 2 to 2, and 2 to infinity. So test points. Let's go negative 3, 0, and 3. So graph calculator. we're going to put this one here in. So I'm going to delete these and clear that. So entire top, 30x squared plus 40, close parentheses, divide, double parentheses here, for x squared minus 4, close parentheses, raised to the third, close parentheses. And second graph to get to table, -3, 0, and 3. So positive, negative, positive. Now, they won't always go positive, negative, positive, but they should alternate. So you may also see negative, positive, negative, but it should alternate there. So we would be up, we'd be down, up. So again, point of inflection, which is where it switches. So again, we have theorem 3.8, which is points of inflection. They will happen where the second derivative equals 0, or where the second derivative does not exist. Now, to find the point of inflection, find where f prime of x equals 0 or where it won't exist. Again, it's kind of repeating what's saying here. But if we do this one, x to the fourth minus 4x to the third. I'm too high. So first derivative would be 4x to the third. Bring the 3 down, we have minus 12x squared. Second derivative, bring the 3 and have 12x squared minus, bring the 2 down, 24x. So find where it equals 0. We don't have to worry about where it doesn't exist because we don't have a bottom in this case. So we could pull a 12x out and have x minus 2 left, which is set equals 0. So x would equal here 0 and 2. So they're going to be our dividers. So negative infinity to 0, 0 to 2, and 2 to infinity. Let's go -1. We can't do 0 here. 1. Wow. And then 3. So I'm going to put in this right here into my y equals. So 12x squared minus 24x. Second table, and delete these out. I'm going to put in -1, 1, and 3. So looking at this, we go positive, negative, positive. So we'd be up, down, up. Okay. So again, worked out that it was positive, negative, positive, but can be negative, positive, negative as well. Now, finally, theorem 3.9, second derivative test. This is why it started to say. So what we're going to do is we're going to do the first derivative, set equals 0, get those critical numbers. Those critical numbers we're going to put into the second derivative then. If we get a positive number when we put that critical number into the second derivative, that means it's a minimum at that point. If it's a negative, then it means it's a max at that point. And if it equals 0, then the test fails. There's no max or min. So first derivative test determines, or second derivative test. This is what I'm good at. So then we would use that first. If it fails, you'd use the first to determine whether it's not. So first thing we're going to do here is first derivative. So first derivative, we bring the 5 down and have negative 15x to the fourth. Plus, we bring the 3 down and have 15x squared. So if I set this equal to 0, I could pull negative 15x squared out, which would leave me with x squared minus 1, which would be negative 15x squared, x plus 1, x minus 1. So all this is set equal to 0. So x would equal, this would go to 0, negative 1, and 1. So, other part of this I need to get is the second derivative. So if I do this again, 4 times 15 would be a negative 60x cubed plus 2 times 15 would be 30x. And so that's what I'll put in here. Now, point here. So we're going to be at negative 1, 0, and 1, which is the x value of this. So I'm actually going to do two things here. So in my y equals, I'm first going to put in the original of negative 3x squared. No, x to the fifth. Wow. Let's clear this out. Negative 3x raised, and we can put to the fifth. So use your caret button to raise it to the fifth. Arrow to the right to get out of it. And then it's plus 5x. Again, use that caret button to get to the third. So that's going to be my y1. My y2, I'm going to put in the second derivative. So negative 60 x raised to the third, arrow over, plus 30x. So when I hit second table, now I can put in my negative 1, my 0, and my 1. So what this tells me is two things. So first column is going to be what y equals of my point. So it's negative 1, negative 2, 0, 0, and 1, 2. So then I use my second column to look at sign. Well, I get a positive, then I get a 0, and then I get a negative. So what that tells me is that negative 1, negative 2, this is going to be, since it's positive, a min. Since we got a 0, the test fails. And because this is a negative, this is going to be a max. So that's how the second derivative will work. That's what this stuff will tell you. It'll tell you what's a max or a min. Now here, because this failed, we would technically have to go back to the first derivative test and look at, okay, where are we increasing, where are we decreasing, and determine whether it's a max or a min. And that's it. That's it for this lesson. So, questions, comments, concerns, please pan me, email me, send me a message on Google Classroom. Remember, you can always pause and write stuff down if you need more time, or you can rewind it, hear stuff again. Don't be afraid to do that. Use that to your advantage because these are videos. Otherwise, until next time, we'll talk to you later.